of a force. Moment of a force. Right. Moment of a force. Moment of a force. Now, when we are talking about moment is force times distance. Moment is what? Force times distance. So, the moment of a force about a point is the product. The moment of a force about a point is the product of the force. The moment of a force about a point is the product of the force and the perpendicular distance of its line of its line of its line of fraction of its line of fraction of the line of fraction from the point. Now let's write the formula. Moment of a force is equal to moment of a force is equal to force times perpendicular distance. Force in Newton times perpendicular distance. Force times perpendicular distance. No, your force is Newton. Your force is Newton and the distance is in meter. And the distance is in meter. Now we can write the principle of moment states that 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 when a body is in equilibrium, the principle of moment states that when a body is in equilibrium, the principle of moment states that when a body is in equilibrium, the sum of the anticlockwise moment, the sum of the anticlockwise moment, the sum of the anticlockwise moment about any point is equal to the sum of the clockwise moment is equal to the sum of the clockwise moment about the same point. About what? The same point. About the same point. Moment about any point is equal to the sum of the clockwise moment. Sum of the clockwise moment. Sum of the clockwise moment about the same point. About the same point. About the same point. Full stop. In addition, comma. In addition, comma. In addition, comma. In addition, comma. The sum of the forces. The sum of the forces in one direction. Sum of the forces in one direction is equal to the sum of the forces in opposite direction. The sum of the forces in one direction is equal to the sum of the forces in opposite direction. Because the sum of the forces in opposite direction is equal to the what? The sum of the forces in opposite direction. Now, look at this. Now, when we are talking about clockwise, how does clock move? Clock move like this, Abi. Why anti-clockwise is like this, Abi. So you take the moment to the pivot. This is the pivot here. So you do like this. You do like this. Are you with me? So this one is anti-clockwise. Why this one is what? Clockwise. So we now say, okay, the sum of the anti-clockwise must be equal to the what? Clockwise. For something to be balanced like this. The sum of the clockwise is equal to sum of the clockwise is equal to what? Anti-clockwise. Instead of to be listening, you are busy looking at me. Is equal to what? Anti-clockwise. So when this thing moves like this, anti-clockwise, that's why we say M1. You have to convert this one to force because our force is equal to mg. So m1g times the distance d1 is equal to what? M2g times the distance d2. Now, coming back to this question here. Everybody listening, oh, those people that are following us online, please listen. Now, say a body of mass 58 gram is suspended. Look at it. Solution. When they say meter rule, the length of the meter rule is 100 centimeter or 1 meter. 100 what? Centimeter or 1 meter. They say 58 gram is suspended out of the 100. They are suspended what? 20. So this place, from here to here, 20 centimeter. They now put a mass of what? 58 gram. Are you with me? And on a uniform meter rule, the meter rule is adjusted until the pivot is able to what? To settle where? 40 centimeter. That is from here. The pivot, 40 centimeter. Determine the mass of the meter rule. So the meter rule can be anywhere here. Let's call this one M2. Now, from here to here will be what? Distance from here to here is what? 20. God bless you. This will be 20. But we do not know the distance from here to here. You can say S. Are you with me? You can say S because they did not tell us where this one is stopping. But, hello, if I have from 0 to 100, if I want to balance this thing, what will the weight act on? 50, Abi. So the weight will act on the middle, 50, half of it, for it to balance. For it to balance, the weight will act on the 50. So for it to what? To settle horizontally. So determine, so the weight will act on this place. 50 centimeter. Are you with me? For this thing to balance, for example now, if two, for example, two boys are sitting down here. Maybe this one is 100 kg. They are doing janglova, that seesaw. If another person must sit down to equal this thing to be balanced, it will be what? 100 kg. If there are two boys that are sitting down here, that means to be 50-50, so that the balance weight will be balanced like this. Are you with me? So that means from here to here is what? 10 centimeter. Are you with me? So you now do